So now we will see the working principle of transformer and construction of a transformer. So basically we have two experiments in the lab to conduct. One is transformation ratio and to find out the transformation ratio of a single phase transformer, and one more experiment is on conducting open circuit test and short circuit test on a transformer to know the efficiency of the transformer and to know the losses in the transformer. Basically the construction of a transformer, it is having two coils. One is primary coil and the other one is secondary coil. Where the input connection is given to the primary coil, and secondary coil side voltage will be induced. So transformer will work on the mutual induction principle. Mutual induction states that the current connected in one coil causes the current to induce in the other coil. So that is called mutual induction. So we have two coils. You can see this is one coil and this is another coil. You can see in this transformer portion, and this is iron core. On the iron core, we have a two windings, that is primary winding and secondary winding. Primary winding side I will connect to the input power supply, and we have no connection between primary coil and secondary coil. It is separated by the iron core. You don't have any connection between primary and secondary coil. So these two terminals are the secondary coil which is connected to the bulb, and primary side I am going to connect it to the input power supply. When focusing on the working principle of a transformer, it is a static device. It is a static device, works on mutual induction principle. It states that the current connected to one coil causes the current to induce in the another coil, which is kept at nearby the current coil. So how the current is induced in that other coil which is not electrically connected? We will see. That is only the mutual induction. So we have an iron core which is the path for the magnetic flux. Every current carrying conductor will produce a magnetic flux. Since the AC is given to the power supply to the primary coil. So now it is input is connected, switch is in off state. So when I switch on the power supply, AC will flow through the primary coil, and which will produce the magnetic flux, and this iron core is good conductor for magnetic flux. The current will be passes, the flux will take the path of the iron core and reaches to the secondary side of the coil, and when flux is going to cut the conductor, EMF is induced. So how much EMF is induced depends on the turns we place at the secondary side. If the turns is very less turns are placed, so less voltage. More turns are placed, more voltage. Faraday's laws of electromagnetic induction first law states that whenever the flux cuts the conductor or conductor cut by the flux, EMF is induced. The second law states that the induced EMF always depends on the rate of change of flux. If the conductor turns very less, the flux produced, even though by the high voltage which is connected to the primary coil causes more flux, and even though more flux is there, but the interaction with the less number of turns, so the d phi by dt change in flux rate is less, so less voltage is induced in the secondary side. Suppose I am going to connect to the 230 volts of power supply, but the output side I have placed a less turns, so less voltage is induced. You can see the intensity of the bulb when it is glowing very dim. So I will switch on the power supply. See, the bulb is glowing dim. That means the output voltage will be less, but the input voltage I have connected to 230 volts. This is about the construction of transformers. So transformers are step up and step down. We are connected to 220 volts. It is going to step down because the turns placed at output side will be less. So d phi by dt rate will be less. So less voltage is induced in the secondary coil. So step down. 220 is step down into 115. Suppose, let us say 115. By taking 115 voltage, bulb is glowing very dim. If 115 is given to the secondary coil, it will produce a flux. Since the voltage is less, flux also less number, and it is going to interact with the more number of turns. So d phi by dt, change in flux rate will be more. So more voltage is induced at this. So that type of transformer is called step up, step down, and step up transformer. So in this transformer, we are going to perform two experiments. One is transformation ratio and turns ratio. Turns ratio means we will give high voltage and vary the high voltage by means of a single phase variable for 50, 150, 200, 230. So simultaneously, we are going to note down the voltages induced in the secondary. So the ratio of both voltages will give you the turns ratio or the transformation ratio. So like that we have an experiment, and if the transformer efficiency is calculated, we have two methods. We have to conduct open circuit test and short circuit test. Those are the experiments on transformers.